Welcome back to my channel. As promised, I've been working for weeks on the upgrade of my D9 to a Hemera Revo nozzle. Today, I'm going to bring you up to speed. Hopefully we'll get it done. We'll get it on there. Try to make this as quick as possible. Stick around. So before we zoom in on this and get to work on putting this all together, I've actually spent quite a bit of time designing most of my own mounts for this thing. Okay, here is the Hemera Revo nozzle. This is the way it came out of the box. If you remember, look back on my unboxing video. This is just standard the way it came out of the box. Okay, and this is the plate for the X-axis on my Monster D9 500. Then it's hooked to the belt and everything. This is the way I took it off the printer. So this is the part that the printer actually moves left and right to do the print. So I did have to drill some holes in here, which we're probably not going to go over real closely, but what I want to do is I want to just take you piece by piece what I designed. I got STLs for the whole thing, so if you try to copy this, you could absolutely copy this. I'm hoping that this Revo Hemera makes this printer more usable than it's ever been. That is my goal. I want to have different nozzles for different filaments, and I'd love to have the quick change nozzles for 0.4, 0.6, and 0.8 at least. So I'm going to end up with a bunch of nozzles, be swapping those back and forth. It'll be great. This printer is a beast. It can print huge stuff. I really got to get this extruder business locked in so that I can get everything taken care of from the beginning to the end. All right, so stick around. Let's zoom in here and I'll show you everything that I've been doing right here on the desk. So here's my mount plate. It goes on the printer so that the print head, the Hemera, needs to go on just like that. So the first thing I needed to do was print a bracket that would go on my D9 that would go up and over and onto the carriage for my X rail. I have linear rails on my machine on the X axis, and so this is what I came up with. The STLs will be in the description. It screws on pretty easily. I had a little bit of trouble making sure all the screws worked and everything went where it needed to go, but I've got some inserts here for some square nuts. Make sure that square nut's in there nice and flat. So this one I put in there just kind of keep it steady while I put the rest of this in. Some of this can be kind of fiddly because these little square nuts that go in the back side of the Revo here, of the Hemera, they just fall right back out. Like they're kind of tough to keep in there. So they just fall right out. So I gotta be really careful, make sure everything's lined up properly, and go ahead and start screwing stuff in. And it ended up that this one right here was just kind of an extra hole that I could use to keep that on there all tight and make sure everything lined up to put the rest of the screws in. So I get those all lined up so that I can see through them just fine. Tighten that down, keep it tight. I got one of the square nuts in there. I can go ahead and put this on. This is going to go on like this. You gotta be really careful with your screw length on the Hemera, because if they go in too deep, they can damage the stepper motor. It's a pancake stepper. It says in the instructions that you get basically 3 to 3.5 millimeters of play there, of depth on your screws. So I've got that one in, it's just fine. These two up here are captive, so you don't have to worry about them falling out. So I'm gonna go ahead and do them next. Notice I'm also not cranking anything down super tight right here, right off the bat. I just want to make sure everything threads in properly. And then I cut that in just perfect so that my tool could get in there. Tighten that one down. Now that I got them all in, I'm going to go ahead and tighten them all down pretty good. They should be pretty straight. Everything should be where I left it. So that is part one. This I did a lot of testing with. This fits on the X-rail just fine. So I went on to step number 2. The second thing that I needed to build, design for this, was I needed a fan shroud. So here's my fan shroud that I came up with. It works pretty good. I found out that I designed the fan shroud, and then I found one that was already designed for me. So the bottom of this is based off of a Prusa Mark III fan shroud, and then I just attached the tabs up to here. The Prusa stuff is pretty much open source, so and then I set it up so it could be adjusted fairly easily with the slots in that part of the print. So I want to make this kind of loose there, and there's a reason why I'm not doing the top one yet. You'll see in a minute. And then this 5015 rotary blower style fan fits right in there. It's not real locked down yet, but I got a nice long screw that goes in there. So we'll crank that down. That'll hold the fan into the fan shroud and bracket, which is holding it onto the Hemera. I just want to make sure that this is all nice and flat and lined up. And I've already done a little bit of testing on the airflow here. This flows basically down out of here pretty hardcore, so it's not actually hitting the nozzle in this position. It will go completely right underneath the nozzle. It barely touches this silicone ring with the air flow. I tested that with a piece of paper from the back. So if that's all nice and lined up, then I'm good to go on that for now. So now the hardest part number 3. This is a part that I had to design from scratch by myself, no helps. It needs to do 3 things for me. First thing it needs to do is it needs to hold my BL Touch off to the side. So that's what these are for. Second thing it needs to do is I needed it to hang on to the daughter board, because this printer has a daughter board that goes on the print head. Everything plugs into this, so I needed a place to hold the daughter board. And then the third thing that I needed it to do was I needed it to provide some kind of strain relief for the main wire that comes up out of here. I don't need that really scraping on stuff or bending too much, or I don't need it having all the stress. So the third thing this does is it's going to create some stress relief for that wire with this little armature right there. So it's a three function part, and it is a little bit fiddly to get it installed. So it can take a minute. If you just hang with me for a second, I will time lapse this, and you'll probably see me have to back up a couple of times because it's a little bit harder than you would think. Alright, so I've got that installed. That's on there. It's got a couple of screws here, which solidifies this bracket for the fan and lines it up just nice and neat. I have a couple of captive square nuts in there for my BL touch sensor, and everything should be ready to roll on that. Now, to add the BL touch sensor, I'm going to do a couple of things. Here's my BL touch bracket. It's pretty small, and here's my BL touch. I just want to make sure that the BL touch wire goes up the back in. There's a cavity that I programmed in there or designed in there for it. I want to make sure that that cavity is not pinching the wires or anything. There's going to be some other wires go up there as well. So there's the BL Touch on the bracket with the wires where they need to be. And now I'm going to tip this sideways here. And I am going to make sure that these wires coming from the hot end go in that same groove so that nothing gets pinched. So there's the BL Touch, and I want to make it straight as possible, and its depth this direction according to the instructions. I might have to set later because it wants the tip of this to be no more than 4 millimeters above the tip of the nozzle. So I might have to adjust that once I get it back on the printer. But there is the BL Touches on there. Next part, all I need to do, I've got this collection of wires going. I need to mount my daughter board. And I want to make sure this is where the filament loads right here. So I want to make sure that doesn't scrape on the daughter board at all or short anything out. I'm probably going to move that a little bit further away from that, just with the slop I've got in those screws. So there's my daughter board. Now, let's talk about wiring for the extrusion motor for a second. So I don't know if that's backwards or not. We got A, B, A, B. This is the wiring diagram right off of the E3D website for the pancake motor that is on the Hemera stepper, or the pancake stepper that's on the Hemera print head. Now, here's the issue that I had. I had a serious issue because the D9 comes with a cable that looks like that, and the Hemera comes with a cable that looks like this. Okay, now the end that goes into the motor are the same. So here's the end. I just cut it off of there. So the end that goes in the motor, they're the same style of connector. But here's the problem that I had. On the motor that they used for the Hemera, the windings, winding A is on pins 1 and 4. Those are windings A, right? Winding B is on 3 and 6. Those are winding B. So I tried just putting everything back where it needed to go and whatever, and I seriously, in the end, I had to look it up. Okay, I had to go, the motors that are on the D9, which is what they're originally wired for, the motors on the D9 are from a company called Moon's Motors. So this is the E3D one right here. On the Moon's motor, the pinout is completely different. The pinout for the A winding on the Moon's motor is on 1 and 3. Those are both A, and the B winding right here is on 4 and 6. So the windings are completely different. So the first time I tried this on the printer, I got nothing. Okay, so I did, in order to figure this out for sure, I hit these windings with a ohm meter. So on the E3D motor, you're supposed to have between the 1 and 4 for that particular winding is supposed to be 2.3 ohms. Okay, so I checked that and it was right. And the winding between for B, B and B was also supposed to be 2.3 ohms, which is fine. That's fine. So then I checked down here, and between A and B, I got nothing. Between 1 and 4, where I thought A was, I got nothing. And between 3 and 6, where I thought B was, I got nothing. So I checked it with A and A on 1 and 3, and I got my resistance. For Moons, I think it was 2.5, I don't remember exactly, and then 2.5 for this one as well. So when I checked it with the multimeter and did some diagramming a little bit, change it around, fix it up, whatever I had to do to figure out the windings for the Moon's motor, I ended up basically swapping pins 3 and 4 on the connector, but then when I went and plugged it into the printer and tried to extrude, it actually retracted. When I tried to retract it, extruded, so this was backwards. So in that case, you need to flip other wires. And in the end, here's what I ended up with. So this is the original wire with the colors. Didn't change these. These are the way they came out of the Hemera. This end, this is just a JST connector, 4-pin to 2.58 millimeter pitch. All right, I got me a crimper, and if you want to see that, here's what my crimper looks like. Pretty nice, it worked pretty good. Steep learning curve, trying to figure out how to make it work though. So if you get one, don't get frustrated with it too fast. Anyways, so I crimped my own ends on there, and this is the formation I came up with. So on the design that I just showed you right here, this would go this way. So this is pins 1, and then 2 is empty, and then 3 and 4, and then 5 is empty, and then 6. That came with the Hemera. And then to make it match the Moon's motor in the correct orientation, I ended up with this color combination, and this does actually extrude, and this does actually retract just like it should. So there's that. Back to the print head. I believe I am going to use the original. So this one is wired correctly as well. So I just color coded these, and then they go in the right pins over here. But this is the one that I'm going to use on this motor. So maybe I should have plugged this in before I put the so I'm going to loosen this up. Give me a little more room underneath there. There's plenty of room for the wires, but there's just not enough room for my big fat fingers. I do have kind of man hands with big fingers, so that's all right. I'll just pull this out of here real fast. So then this connector is going to go right in there. Nice black wires, look very nice. And then I can go ahead and put this back on. Another thing that I did with my 2.58 millimeter pitch JST kit was these cables. These are the cables that came with the Hemera right here. So I just chopped the end off to have the end that I need. So I'm just going to plug these right in. So this larger, heavier one is for the heater element, and this skinnier white one, thinner wires, is for the thermistor. Now, to make this compatible with my D9, I did have to get a Hemera end that used a 1K thermistor in it, because it's all one piece, it's all built in. And the thermistor that they originally had, or the piece that originally came with mine, didn't have the 100K thermistor in it. And so it gave my printer a lot of guff. And I don't really want to go into the firmware and change it. The D9, the Wanhao people don't like that. But E3D offered an upgrade, a little upgrade kit. So this is actually the E3D hot end with the correct thermistor in it. I've already tested that. It gives me good readings. Doesn't give me any errors or anything. So that works great like that. So now I've got wires here. In order to make sure that everything came out, goes back in the same way it came out, I actually took a picture of it. I don't know that I needed to take a picture of it. They have this online, but I just took a picture of it, and so now I know where everything goes. So I've got my thermistor. We'll put that here in the slot for the thermistor. Actually, you know what? That'll just get in our way. Okay, let's do the fan for the heat. Fan for the heat break. Goes right in there. The motor. I got to spin this around a little bit, but the extruder motor connector will go right in there. like that. The BL Touch, it's got a super tiny connector on it. I hope that doesn't break. We'll go right in there. Use my little tool maybe to push that in. My big fat fingers. There we go. That's for the BL Touch. And then we can put the thermistor, which if you get confused, it's the smaller wires. It's the white one. So the thermistor goes right there. Get that pushed in there. The part fan, which also I had to put an end on, because those part fans come with two like a meter's worth of wire, 2 or 3 feet at least. That can go right there. And then here's for my heater cartridge, goes right in there. And this plug on my particular printer is completely unused. So there it is. That's what the monster is going to look like. Last thing I want to do is I want to get this, if you remember, I was talking about a strain relief for this main cable that comes up here. And I might redesign this, put some grooves in it, maybe for some zip ties, whatever. I don't know how well it's going to work. I've never tried it before, so this is the first time for me and for you. Let me find a screw that actually is the right length to go in there. We can check that out. So I think that screw will be good. It kind of goes down into the part that I've already made, but that's fine. So this screw should work pretty good. Get that in there. Before I tighten that down, check my clearance and stuff. It looks pretty good. Like I said, this particular part might need to be redesigned a little bit in the future. I hope that it's strong enough to hang on to that for me. Feels pretty good. It's not super thick, but it feels pretty good. Okay, so that should be pretty much everything that needs to happen. I don't know about, I might tie these down a little bit or put a zip on them. I don't know. I hesitate to mess too much with the BL Touch wires. They're super tiny, so they can just stay wherever they're at. So anyways, there's that. We're gonna head over to the printer now and we can get this totally installed, and then we will have to configure it. We'll do a PID tune, and then we'll have to make sure that we have the E-steps on the extruder correct. I do have videos for that already, but no biggie. I'll show it if you want to stick around. Let's move over to the printer.